Okay, all right. Well, happy Friday, and thanks for being here. And hope you've had a good week. Hope your midterms are going well, and good luck to any future midterms as well. Okay, well, this week we've been looking at Pandas. Pandas is the library, the module that we load into Python so that we have this data structure called the data frame, right? So in base Python, we don't have data structures like data frames, okay? In base Python, we have lists, we have tuples, we have dictionaries, all very useful, but no data frame. And so NumPy introduces the array, and Pandas introduces the data frame. A data frame is basically a collection of arrays arranged in this two-dimensional table type of thing. Okay, so there are a lot of kind of operations that we can do in Pandas, where we can do kind of summaries and pivot our tables, and we can also run group by operations. So if so a lot of you, well, all of you have taken Stats 20. Some of you have taken Stats 102A. I am just kind of curious, who is familiar with dplyr from R? So there is kind of the tidyverse and dplyr, and we're kind of familiar with that. A little bit familiar. It's, I guess, depending on who you take Stats 20 with, you may or may not cover dplyr. And so, but anyway, there are kind of a lot of tools in here that overlap or do synonymous things that dplyr does. So if you're familiar with dplyr, a lot of these things will feel familiar. If you're not familiar with dplyr, I do think there's kind of this logical way to do it, or to think about it, and I hope I have enough examples here to for it to kind of make sense. Let's go ahead and take a look at our notebook here. And as always, you can do your git pull upstream main. There's today's notebook as well as a CSV file that will be in the latest commit. Okay, so we'll load up Pandas. We'll load up NumPy. I also imported Matplotlib. I don't actually think I use it, but not in today's lecture. But we'll go ahead and load that up. Okay, kind of the structure, the thing that enables us to do a lot of our pivoting and a lot of our summarizing and things like that is known as the multi-index or the hierarchical index as far as a data frame goes. And so in Pandas, all of our data structures within Pandas have an index. The series has an index, and when you create a data frame, that also has an index. And so far, the index, we've kind of treated it as like row names. Okay, it's kind of been like the row names, and most commonly the index is like the integers going from 0 to n, kind of like that. But here I'm going to create a hierarchical multi-index. And so you'll notice here I'm going to create a series, and the array is going to be just some integers. And the index is going to be, you'll notice the index itself is a two-dimensional array. I've got 2 rows within this array and 9 values, because my array, the original array that I'm attaching, creating a series out of, has 9 values. And so the index, I have AAA, BBB, CCC, and then kind of the second level of the index is 456, 456, 456. Okay, so I'm going to go ahead and create my series here, and you can see this is what we have. After I create my multi-index, the index appears on the left-hand side, and so we have AAA, because the A, this is A4, A5, and A6. The A's repeat here, and so the default printing method is to hide the additional A's. So this is, even though it's a blank 5, this is understood to be falling under the A above it. So this is A4, A5, A6. Then we have B4, and again, even though nothing shows here, it is B5 and B6. And then I have C4, C5, and C6. And then just for your own sake, as far as the integer values here, I treated the A as if it were a 1, a B as if it were a 2, and C as if it were a 3. And the integer values that appear here is kind of the product of basically A, times 4, B times 4, 5, 6 gives me 8, 10, 12, and C being the 3 times 4, 5, 6 gives me 12, 15, 18. Just because as I'm going to do operations here, I want to make sure you can kind of see these relationships here. Okay, so if I ask what is the index here, we're going to get a multi-level index, okay? And it's going to be listed off as kind of a list of tuples, okay? And so we can see we have the A4, A5, A6, B4, B5, B6, C4, C5, and C6. So this is the index that's associated with these values. And so this is still just a series, okay, of 9 values, but we have this kind of index here. And so when you say, I have my series, and if we use the .loc to kind of subset, you can say I want to subset to the locations where the index is B. And what this is going to do is it's going to subset basically these 3 rows. And so normally, if you have a regular old index and you subset to kind of one value, it will return just that one value. Okay, but here I'm subsetting it to B in this multi-level index, and we're going to have three values here. 8, 10, and 12 associated with B. And it's going to actually return a series itself where you have an index of 4, 5, 6. Okay, so I'm going to let me just kind of show you here. So if I do .loc at B, I get another series, and it's basically I've taken this here, and I got the 8, 10, 12, but it also comes with the index of 4, 5, 6. It doesn't include the B here, it just includes the kind of lower level index because we've selected or located just this B. If you want to select, you can also select via the second level of the index. And so here we have the 4, 5, 6, 4, 5, 6, 4, 5, 6. And you can say, I want to pick out the rows where the second level of the index is a 5. Okay? But in order to select kind of via the second level of the index, you would say for the dot locator, okay, you would say, I want everything at the first level, and I only want where the second level is 5. Okay? So this will give me basically the 5 here, the level 5 here, and the level 5 there. So we have A is 5, B is 10, and C is 15. You can't do, like if I do data loc 5, okay, this will return an error here because as far as kind of the first level of the index, the first level in the index only has A, B, and C. And so, so here, actually, yeah, it takes a while to figure out that this is going to return an error here. Okay. If I ask what is the type on this, can we see what is the type on data.loc : 5? This will be a pandas series. Okay, this is a pandas series where we have the index is ABC. And if I ask what is the index on this, the index is just a normal index, not a multi-index, and it's got the values ABC in it. Okay. So if here's my series where I have A4, A5, A6, B4, B5, B6. Okay, I can take. Let me just kind of, just for your reference, let me just show you. This is what our series looks like. I can use this operator or this method unstack. Okay, Now, what you're going to see throughout the rest of this is method chaining. So every time I'm going to use a method, one of the object's methods. So here my data is the series, and I'm going to call the method unstack. Okay, unstack parentheses, and this is going to it itself is going to return a data frame. Okay, and then if I want to get information from that data frame, I'm going to just kind of chain either series or attributes from it. So here I'm going to do data.unstack, and what you can see is here it treats the 9 values I have here as if they were kind of stacked together, and we are going to unstack them, okay? And so here what I had was the A4, B4, and C4 kind of becomes its own little column here. I get a column for 4, a column for 5, and a column for 6. I'm taking the inner level index and I'm kind of unstacking them. I'm pivoting them wider is what we would say is what we are doing, is we're taking these values here, and rather than going A4, A5, A6, I'm kind of creating a grid where I have one row for A and a column for 4, 5, and 6, and a row for B and a column for 4, 5, and 6, and so on and so forth, right? So this contains the same information in a little bit more of a compact space here. Yeah, question?
I'm kind of confused with the select linear index notation. So like with the colon inside the brackets, it's also it's kind of like the slicing, right? But then you first select the entire thing.
So yeah, with the comma in the in this, it looks like, it looks like data here is almost like a two-dimensional matrix, but it's not that we have a two-dimensional matrix. We have a two-level index. We have a hierarchical index. So you have kind of the first level of the index, which has A, B, C, and the second level of the index, which is 4, 5, 6. And in order to say I want all of the values, either A or B or C, okay, I'm basically slicing all of the values. So I'm pretty sure I am not allowed to just leave this blank here, okay? So unlike R, where you can kind of leave things before or after the comma is blank, okay? You can't do that in Python. And so if you want to say, like, I want all of the, and it's not rows, but basically we want all of the values at the first level of the index, whether it's an A, a B, or a C, then I would use kind of this slice notation. Now, if I only want just level A, I can do that, okay? Or if I want A or C, I can put that into a, oh no, that doesn't like that. What is this? It doesn't like, can I do, maybe I do. Let me just check my notation here. Okay, so you can create an array containing A and C, and you can get just top level A or C, and then second level 5 here. Okay, you can put that into an array. You can't just put it straight into a tuple, I guess. Okay, or you can say all of the values using the colon. Does that kind of clear up what's happening? Okay. Okay, so yeah, let's talk about unstacking. So here I've got this. I have my series, which has the two-level index, AAA, BBB, CCC, and then 456, 456, 456, and I can unstack it. Okay, and so here I'm going to do data.unstack, and I get this 3x3 data frame, and I can, I'm going to chain. All right, so I'm not creating a new object yet. Okay, I'm just still calling data, then I'm unstacking it, and after I'm unstacking it, I'm going to ask what is the index. This index is no longer a multi-index, it's just the regular old index with basically row names or values A, B, and C. All right, and we have that. If I do data.unstack.shape, okay, so data.unstack is this data frame here, and what is the shape of this data frame? How many rows, how many columns? 3 by 3, right? So that's exactly what we get. We get 3 by 3. The inverse of unstack is stack. And so this is kind of silly, but I can do data.unstack, and then I can stack that. So I'm basically taking, here I have this 3 by 3 data frame. When I do data.unstack, I have this 3 by 3 data frame. And if I take this 3 by 3 data frame and I call stack upon it, okay, then I get back the original same series that I started off with. Okay, so you can also just kind of take an existing data frame and you can call stack, and it will stack the values into a series here. Here, if this is my data where I have AAA, BBB, CCC, and 456, 456, 456, you can also take this multi-index and you can swap the inner index and the outer index. So here, I would end up getting 456 on the outside and ABC, AAA, BBB, and CCC on the inside. When you call swap level, it does not change the order of the values themselves. So the order of my values are still 4, 5, 6, 8, 10, 12, 12, 15, 18. Okay, and so now we have 4, 5, 6 on the outside and then AAA on the inside. Okay, so this is what happens when I do swap level. Even though the A's repeat here, okay, we don't have this kind of A blank blank 5. I mean A4 blank 5 blank 6. Okay, we have 4A, 5A, and 6A, just because the outer level index has changed. With something like this, I can still select, I just want the values where the inner level is A. And so here, if I do data.swapLevel.location : A, I'll get 4, 5, and 6 with index levels at 4, 5, and 6. Again, the default behavior is not to change the order of the values, but after you swap levels, you can sort by index, and it will sort on the first level, and you will get 4A, 4B, 4C, 5A, 5B, 5C, and you can see here, now that we have 4A, 4B, 4C, kind of the next value, instead of listing out 4B and 4C, those values appear blank here. Okay. Again, in all of these things, data remains unchanged. All of these operations where I call swap level or unstack or stack don't actually affect the original data object themselves. They return kind of new copies where the original data is unaffected. Okay, so here's a question. So here I have data.swapLevel gives me this thing, and if I call unstack on this, or my swap, so I have 4, 5, 6, 4A, 5A, 6A, 4B, 5B, 6B, and if I were to call unstack on this, what am I going to get? So I got data.swapLevel, so I'm going to swap my levels, and then I'm going to unstack. Is that going to be different from data.unstack? And how is it going to be different? Yeah, so they'll basically be like transposes of each other. So data.unstack produced the rows A, B, C, and the columns 4, 5, 6. And if I swap levels and unstack, now I have the rows 4, 5, 6, and the columns A, B, C. Okay. So again, comparing that to data.unstack, we can see, yeah, indeed, they're kind of like basically transposes. All right, because when you unstack it, and you have this hierarchical index, it unstacks the inner level. Okay, the inner level becomes the columns. Okay, so again, original data is this series where I've got this hierarchical index, and I can call sum. Okay, when you call sum, it's going to treat all of these values. We've got all kind of 9 values here, and it's going to add them all up. We get a sum of 90. But you can also call sum by kind of grouping on different levels of the index. So you can group by level 0. Level 0 is going to be the top level index, which in the original data is A, B, and C, and we can call sum on that level. So we will get a sum for A, a sum for B, and a sum for C. So basically 4 plus 5 plus 6 adds up to 15, and then B is going to add up, the values in B are going to add up to 30, values in C will add up to 45. Okay. Okay. You can also group by the second level of the index, or index level 1, which is going to be grouping by the 4, 5, and 6, and you can call sum there. And here we get, what is 4 plus 8 plus 12 gives us 24, and what's 5 plus 10 plus 15, and it gives us 30, and so on and so forth. Okay, let me go ahead and give you your first view quiz answer. Question 1 is B. Okay. Okay, so that gives us kind of an introduction to this concept of a hierarchical index, and with that in mind, I would say we don't often work with a single series with a hierarchical index alone, okay? But we frequently end up working with that in the context of having a data frame and then kind of reshaping our data frame or pivoting our data frame. So when you take a data frame and you pivot or reshape it, you end up kind of creating these hierarchical indexes, and that's when you're going to be kind of most frequently working with this ideas here. Okay, so I'm going to create a very simple data frame. This is going to be a 2x3 data frame. My rows, okay, my index, basically my row names, I'm going to have alpha and beta, and I'm going to call this index letter. And then the columns, I'm going to have column 1, column 2, and column 3. And the name of that, like the column, name of the columns, we're going to call number here, okay? And then here I'm going to just take the values 1 through 6, okay? So I've got basically alpha, row alpha has 1, 2, and 3, and row beta has 4, 5, 6, and then the column names are 1, 2, 3. Okay, so when I call data.stack, I can take my data frame, a 2x3 data frame, and I'm going to call stack on this, and this is going to take these 6 unique values and stack them into a single series and create a multi-level index, right? What will my 2 levels of the index be, or what do you think the index levels will be? We'll have alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3. We're taking the columns and we're going to create the inner levels of this, right? So we get alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, and we've stacked the values that are arranged here, okay? Again, if I take my stacked series, my series which just has these numbers, and I unstack them, okay, we'll get back our original data frame there, right? So unstack undoes this. There's another thing that you can do. You can call unstack, and by default, unstacking will unstack the innermost index level, okay? But you can specify which level of the hierarchical index to unstack. So here we're going to stack them, and we'll get this, and then I can say unstack based on index 0 here, okay? And so what will happen here is if I so the default behavior is when I unstack this stack, it unstacks the innermost level, which will be level 1, but I can call data.stack and take this series and I can unstack on level 0. And now level 0 will become the columns. And so now I'll get a column for alpha and a column for beta. So this is, in essence, it has the effect of transposing, transposing our results there. Okay, but again, you can kind of just specify all of these things. And again, we see how are we okay with this dot notation for method chaining? So data.stack returns a series with a multi-level index, and then with that object, that series itself has its own methods that I can just kind of chain using the dot notation, right? If this is data.stack, we can unstack, and when we unstack, we can specify the index level. We can say index level 0, unstack index level 0, or unstack index level 1. Okay. You can also unstack the index based on the name of the index. So I can say unstack the letter, or unstack the number, all right? So here I can say unstack letter or unstack number, and it will unstack the index accordingly as well. All right. Here's another example here. I'm going to create two series. These series will have index A, B, C, D for series 1, and series 2 has only 3 values, and its index values are C, D, and E. And I'm going to kind of concatenate these things, and I'm going to provide a multi-level index by kind of calling the keys here, all right? So keys 1 and 2 will basically associate create a multi-level index where the top level index will be, you know, I'm going to have 1A, 1B, 1C, 1D, and then the top level here will be 2, and I'll have 2C, 2D, and 2E. So this is going to be kind of the resulting here. So I'm concatenating these two series into just one longer series using pd.concat, pandas.concat. I'm saying concatenate these objects, series 1 and series 2, and when I do that, I'm providing a key to kind of associate like another level of our index here. All right, so this is what we have here. Okay, what is going to happen if I take this series object, which has 7 values in it, and I call unstack, okay? My top level index is 1, and my 1 and 2, and the second level of the index, my multi-index is A, B, C, D, C, D, E. What happens when I unstack? Okay, I'm going to get a row for 1 and a row for 2, and then it's going to find all of the unique values at the second level and create columns accordingly. So I'll get a column for A, B, C, D, E, and where it doesn't have anything to fill in, it's going to put in NAs. So we're going to get, 1A, 1B, 1C, 1D has the values 1, 2, 0, 1, 2, 3, and then we have a NaN for E. And then for 2, we get, basically for 2A and 2B, we have NaNs, but we have values for 2C, 2D, and 2E. Also notice what happened to our values. We went from integers to floats because NaN is always going to be a float. So that's rarely a problem going from integers to floats unless your integers are really, really, really big. I think the max, so in Python, there's no maximum integer size. You can have a really, really big integer, no problem. I think the max float integer is 2 to the 52 or 2 to the 53, something along that order. Okay, I don't know the exact, I don't remember. Or maybe 2 to the 51. One of those things, 51, 52, or 53 is the max integer size. And we rarely work with integers that big, but if you do, it crashes, okay? Or not crashes, it rounds off, right? So it just rounds off and things get rounded to the nearest like 4 or 8 or something. Okay. If we take this data structure, which has 2 rows and 5 columns, and I call stack back upon this, okay, so if these NaNs were introduced by unstacking and I call stack back upon it, those NaNs get filtered back out and we get our original thing where we have no NaNs and we just have 0, 1, 2, 3, 4, 5, 6, okay? It's still, the key difference here though, when I unstacked and I stacked it, these are now float values, okay? So in almost all I shouldn't say almost all, but in a lot of cases when you unstack something and you stack it back up, you get back the original thing, right? But we don't get back the original thing here, right? We get back now, after I unstacked it, the NaNs were introduced and turned everything into floats. And when I stacked it, it remains a float. The NaNs got cleared out, okay? But now we have floats here. So there's a subtle difference. This would be I'm not going to put this on I don't think I'm going to put this on a test, but I could imagine like if somebody really wanted to kind of like hone in on your knowledge in your understanding of some of these subtleties, this would be like, I think this would really differentiate someone who like is really with it versus probably your average person probably wouldn't even think about something like this. Okay, your average coder, and it's just like, oh yeah, that is something that would happen. Okay, something that you have to kind of look out for. And the nans would only get introduced if there is a mismatch here. So if there is no mismatch, it would remain, no nans would get introduced. Everything would remain an integer, and when you stack it, you get back exactly the same thing. So it is really kind of a subtle thing, but you might suddenly wonder like, hey, why do I have floats here, right? Because if you're working with integers, you kind of do that. Here, if you say drop NA equals false, it will keep all of the nans, and that's what we have here. Okay. Time is ticking away. All right, let me go ahead and give you your second view quiz answer. Question 2 is E. All right, so let's do something that's a little bit closer to like a real life example where we're going to just kind of import a data frame, import a CSV. And so, so this was just some kind of generated data set from the package stats models. And U.S. macroeconomic data from 1959 to 2009, I guess compiled by this, data from the Federal Reserve Bank of St. Louis, except for unemployment, which came from National Bureau of Labor Statistics. Okay, so I guess this is true actual numbers. I don't know anything about macroeconomics here, but it's just kind of a data set that we can look at. You can kind of get a summary on the data just in terms of like what is some of the stuff here. And we have the year, so I guess going from 1959 to 2009, the quarter, and then we have GDP, and I don't know what all of these other things stand for, okay? CPI, Consumer Price Index, stuff like that, okay? Inflation. And then just kind of a head, the top 5 rows of this thing, okay? We have 1959, quarter 1 would be like January, February, March, and then quarter 2 would be April, May, June, so on and so forth. Real GDP, all of this other stuff. Okay, whatever these things are. Okay, what we can do is we can turn these, so we can create an index. Pandas has these nice kind of features that allow us to work with dates. So, seeing 1959 quarter 1 is a little bit, I think, for most people, not as convenient. And so we can kind of turn these into dates. And so there's this, there's a nice little function called period index, which understands this kind of concepts of like first quarter and second quarter, and can create indices based on that. And so, so you can read more about that at the documentation on period index. And here we're going to say, you know what, take the column year from our data. So our data is called, the object is called data. So we can take data.year and data.quarter, and period index understands some of these different time periods like the year and the quarter. There's other things. So you can have day of the week, the month, the week, and something week of the year, things like that. And so you can do that, and then now the periods have things like 1959 Q1. So rather than year and quarter as the values here, we now can kind of create an index that says 1951 Q1, 1959 Q2, and so on and so forth. And I can set that to be kind of the index here. So right now our index of the data frame is just a range index, going from 0. I think there's 203 203 values, so it's going to go from 0 to 202 is right now our range index. Here I want to just select these 3 columns, real GDP, inflation, and unemployment, and I'm going to create a pandas index out of that. Okay, so my columns will just be these 3 things, and I can do data.reindex, right? So remember, reindex takes your thing and it will conform it to some specified index here. And so in this case, the reindex is kind of like the .loc, behaves similar to the .loc here, and I'm just going to end up selecting these 3 columns here. If for whatever reason one of these things weren't one of the specified columns, then it would kind of induce a whole bunch of NAs. But here we're going to reindex using the columns, specifying the columns to be equal to the columns index object that I created here. Okay, and then I'm reassigning that back onto data. So I've stored it back, and so now all of the original thing in data here has been lost. So if I ask like, what is data.head, I've narrowed it down to just these 3 columns. I've lost all of the other kind of columns in here, and I'd have to re-import that CSV file to get that back. Okay. Here I have my period index, 1959 Q1, 1959 Q2, and I can call this function to 2_timestamp. Okay, periods is a pandas period index, and so with the pandas period index, there are different methods. So we have these attributes, okay? And then, so the different attributes are things like the month and the year and the quarter and things like that. And then we also have these methods that we can take the period index and do operations with them. And one of them is to cast the period index into a date-time array or date-time index. And so that's the 2_timestamp, right? And the how, you have this argument 2_timestamp. You can cast either the start or the end of that period. So here I can say, take your period index, change it to a daily value, and use the start. So the start of the 1959 Q1 is 1959 January 1, and the start of the second quarter, 1959 Q2, is April 1, 1959, and the start of Q3 will be 1959 July 1. Okay. If I called E instead of start, or if I called end, then rather than January 1, it would give me the date, the ending date of the index, which it here says that's 1959 March 39 at 11:59 and 59.99999 seconds. Okay, so truly that is the kind of the very last moment of quarter 1 of 1959. Okay, and so on and so forth. But we'll go ahead and just keep it at start.
Is there a way to get rid of the time if you?
Yes. I'm pretty sure there is a way. I don't know off the top of my head. Something. Okay. I always have to check the documentation. I don't know anything off of the top of my head. I'm fairly useless here. Okay. Let's see. How string date. This isn't going to work here. Maybe we just cast it only the date attribute. Let me see. All right, so if I do end, and then if I just say dot. Ooh. Okay. Okay, so here I get a date time object of 1959 331, but I want it as a pandas date object. Maybe there's a to date. No, it doesn't like that. Okay, there's something. I feel like I'm close here, but here I get a datetime.date object, and we would want like a pandas dot. You know what? Maybe it's. All right, I don't know. The answer is I'm sure there is a way, but I don't know yet. All right, but anyway, okay. So right now our index is just this range index, right? And here I want to just replace it with this date time index that I've created with the start dates. So I'm going to just do that. I'm going to just take my periods.toTimestamp index, and I'm just replacing the date.index. So now when I ask what is our data.head, we have the same kind of thing here, except now my index is these dates: 1959 January 1, 1959 April 1, so on and so forth. I can call stack on this. What's going to happen if I call stack? These three things, the three columns, real GDP, inflation, unemployment, will get stacked into one series. And then I will have a multi-index. And the different levels of my multi-index will be date on the first level, and then either real GDP, inflation, or unemployment as the second level of the index, right? So I'm going to get 1959-01, real GDP, inflation, unemployment, and so on and so forth. So this is I get a multi-index here, and then the different values get stacked together in here. Yes?
Could you remind why it stacks by item by real GDP, inflation, and unemployment first, as opposed to the date?
The behavior of stack is to take the columns and stack them together. So, wait, I don't know if that.
Okay, and so if you use the levels equals 0, that would mean to do the opposite.
Let me see. I don't. Unstack. Yeah. Okay. No, we can't do that. When you unstack, you can unstack at levels equal 0 or levels equal 1. So I can do unstack, and I'll get back this. I can unstack level 0, and then the dates will become the columns. But here it's going to kind of create this. Now, if you want, you can swap the levels. Is it swap underscore levels? Shoot. I just did it. Where's swap levels? Oh, swap level. Okay. See, I can't remember crap here. All right. So you can do this, and then you can swap level, and then you can sort index. Now I don't know if I'm spelling anything correctly. Okay, and you can have all of inflation first in 1950. You can do all kinds of these operations here. I don't know if I'm answering your question indirectly, but this is kind of the default behavior, and then if you wanted to do something different, you might have to just chain a couple additional methods or commands there. Okay, so here I can date.stack. I get this multi-level index, and we have that. There's an option, or there's a method called reset index, and what that will do is it will just kind of turn everything, turn kind of all of your multi-level index into columns. Okay, so here we're going to get. So this is a series, and there's only one thing, kind of one series of values here, and I have this multi-level index. What you can do is you can call reset index, and it will take your multi-level index, and it will turn those into new columns. So I'll get a column for date, a column for item, and then the values here just gets a default name of 0, and then the index gets reset to just basically a range index here. So this thing, we don't really have an equivalent of it. ends up something looking like this. Okay. If I ask what is the index here, I get a range index now of length 609, starting at 0. We have a length of 609 because we have basically 203 values and 3 different items, 203 values in each item. Here we can say this is our data in long data format. Okay, so I'm going to do data.stack. I'm going to call reset index, and then I'm going to just rename this last column from 0 into value. And so here, basically, it's the same thing of just kind of pivoting all of our data from 3 columns into. So this here has 3 columns, 203 rows. Okay, a column for real GDP, column for inflation, column for unemployment. And now I have, after I do this, I have 609 rows. Okay, I still have 3 columns, but now my columns are date, item, and value. Okay, and so now I have 3 rows for 1959 January 1, and those rows are real GDP, inflation, unemployment, and I got a value for each of those things. All right, so this is what we would call the long version of our data. So if you have the long version of your data, sometimes you read in data and it comes in looking like this, and you can unstack it, okay? And you want to do that. But if you call unstack on this, it doesn't quite work, okay? Because unstack is powered by a multi-index, and right now we don't have a multi-index. We just have a range index. So if I call unstack on this, it gets confused, and it just says, okay, here's 1,827 values, and it just says, I've got date 0, 1, 2, 3, 4, and so on and so forth, and it just does this. So unstack doesn't work because we don't have a multi-level index. But if you do want this kind of thing where you want to take your data from long and make it into basically a wider format, okay, where you have 1 row for each date and a column for each of these different value types, a column for real GDP, column for inflation, column for unemployment, that's what we call pivoting our data. So here's my long data, 609 rows. I got, 609 rows. I got 3 rows for each date. What I can do is I can pivot, okay? And I'm going to pivot, making an index out of the date, all right? And taking our items, the item column, and turning those into columns, okay? So the format is what's going to become your new rows, what's going to become your new columns, and then what values do you put on the inside? And so when I do that, I've taken my long data, and the result of this is I'm going to now have 203 rows, okay? 1 row for each date, and each item type gets its own column. So I'll have a column for inflation, column for real GDP, and a column for unemployment. Okay? If you want, you can specify things differently. I can say I want my item to be my index, okay? So that will be, I'll have 3 rows now, inflation, real GDP, unemployment. I want my columns to be the date, and inside we're going to put in the values there. And we can also do that, and we're going to get 3 rows and 203 columns. Again, all of these operations leave the original data as unchanged. Okay, we're running out of time here. I think we'll have to look at group by. Let me give you question 3 is D. D is your final view quiz answer for question 3. So anyway, if you have something like a data frame where you have some of these other things, you can also call group by, and you can call summary operations. So you can say group by certain key and call, ask for a mean there. So we can group by key 1, and we can ask for the mean there. Okay, we'll have to end it here for today. We're out of time, so have a great weekend, and I guess we'll take a look at this in a little bit more detail next week. All right, we'll see you guys on Monday.